There is a place in central Arizona where the Earth has given up on life. 50 miles west of Phoenix, the Sonoran Desert stretches out in every direction. A vast, cracked expanse of creosote bush and scorched rock, where summer temperatures routinely climb past 115 degrees Fahrenheit. The air shimmers above the hardpan like a hallucination. Rain, when it comes at all, evaporates before it hits the ground. Rivers here are geological rumors, dry beds of sand that haven't carried water in months, sometimes years. This is terrain that punishes steel, warps concrete, and drains moisture from anything foolish enough to stand still. It is, by every measure, one of the most hostile landscapes on the North American continent. And someone decided to build a nuclear power plant in the middle of it. To understand why that decision borders on industrial insanity, you need to understand a single, non-negotiable law of nuclear engineering. A nuclear reactor is, at its core, a controlled catastrophe. Uranium fuel rods splitting atoms in a furious chain reaction that generates temperatures exceeding 500 degrees. The only thing standing between that controlled fury and a full-scale meltdown is water. Massive, relentless, never-ending volumes of water. Cooling water is not a luxury in nuclear power. It is the single most critical safety system any plant possesses. Without it, fuel rods overheat, containment fails, and you are staring down the barrel of a disaster that makes headlines for decades. This is why virtually every nuclear power station on Earth sits beside a major body of water. The French plants line the Loire and the Rhone. Japan's reactors hug the Pacific coastline. In the United States, facilities cluster along the Great Lakes, the Atlantic seaboard, and the wide, slow rivers of the Southeast. The logic is ancient and absolute. If you're going to harness the most volatile force humanity has ever controlled, you plant yourself next to the one thing that can keep it from consuming you. And then there is Palo Verde. The Palo Verde Generating Station is the single largest nuclear power plant in the United States. 3 pressurized water reactors, over 3,000 megawatts of raw electrical output, enough energy to power 4 million homes across 3 states. It is a colossus of American engineering, a monument to the nation's appetite for energy, on a scale that dwarfs nearly every other power facility in the Western Hemisphere. It also sits on bone-dry desert sand, more than 50 miles from the nearest significant river, with no lake, no reservoir, and no ocean anywhere on its horizon. It is an anomaly, a defiance of every principle that governs where nuclear power stations are supposed to exist. A 3-gigawatt monster parked inside a furnace, surrounded by a landscape that offers precisely zero of the one resource it cannot survive without. So how does a nation keep its most powerful energy fortress alive in a place where the desert itself seems engineered? To destroy it. 20 billion gallons. That is the volume of water Palo Verde consumes every single year just to keep its 3 reactor cores from crossing the threshold between controlled power and catastrophic failure. 20 billion gallons. Enough to fill a lake, enough to sustain a small city, enough to irrigate thousands of acres of farmland. And every last drop of it must arrive without interruption, day after day, month after month, in a landscape where annual rainfall barely reaches 7 inches and the nearest river is a seasonal ghost. Nature was never going to provide this water, so the engineers found it somewhere else entirely. They found it in the showers and sinks and toilets of Phoenix, Arizona. Palo Verde is the only nuclear power station in the world that is cooled not by a river, not by the ocean, not by a reservoir, but by the treated sewage of a major American city. Every day, as nearly 5 million people in the Phoenix metropolitan area flush, wash, and drain. Their wastewater flows into the city's municipal treatment system, and from there, a portion of that gray, used-up water begins a second life, one that ends inside the cooling towers of a nuclear colossus sitting alone in the desert. The artery that makes this possible is the Hassayampa Pipeline, 36 miles of reinforced concrete and welded steel, buried beneath the Sonoran hardpan, carrying a relentless current of treated effluent from the 91st Avenue wastewater treatment plant on the western edge of Phoenix directly to the gates of Palo Verde. It is an engineering vein of staggering scale, purpose-built to do one job, and one job only. Keep 3 nuclear reactors alive in a place where water has no business existing in these quantities. But you cannot pump municipal wastewater directly into a nuclear cooling system. The chemistry would be ruinous. Mineral deposits would choke the pipes. Biological contaminants would corrode critical infrastructure from the inside out. What arrives at Palo Verde through that pipeline is still, by industrial standards, filthy. So the plant operates the largest water reclamation facility of its kind anywhere on Earth, an on-site purification complex that takes the incoming effluent and subjects it to an exhaustive regime of filtration, chemical treatment, and reverse osmosis, a process of industrial alchemy that strips away every impurity until what remains is water clean enough to circulate through the cooling loops of a pressurized nuclear reactor. And then the cycle begins. The reclaimed water flows into 3 massive cooling towers, each one a towering concrete shell rising above the desert floor. Inside, the water absorbs the furious heat, radiating from the reactor cores. It surges through the system, carrying that thermal energy upward until it finally escapes as vast white plumes of steam. Those iconic columns of vapor rising against an empty blue sky, visible for miles across the flat Arizona landscape. The water arrives as waste. It is reborn as coolant, and it vanishes as mist. It is a closed loop of reclamation and evaporation, repeated millions of times over, every hour of every day. The life support system of a machine that should not exist, breathing steadily in a furnace that never stops trying to shut it down. The water arrives, the reactors breathe, and from a distance, the system looks like it has conquered the desert. But inside the cooling infrastructure of Palo Verde, a quieter war is being fought, one that never makes headlines, one that never pauses, and one that the engineers on site know could spiral toward catastrophe if they lose focus for even a few hours. The problem is the water itself. Treated sewage is not clean water. It is reclaimed water, a fundamentally different substance carrying a chemical memory of everything it once contained. Even after the reclamation facility has stripped away the biological contaminants, the effluent still carries elevated concentrations of dissolved minerals, chlorides, and salts. And inside the superheated environment of a nuclear cooling system, those trace elements become a corrosive enemy. As the water cycles through the cooling loops and evaporates, the minerals do not evaporate with it. They concentrate. They accumulate. They begin to form hard, calcium-rich deposits on the interior walls of pipes and heat exchangers, a process engineers call scaling. Left unchecked, scaling does not simply reduce efficiency. It chokes flow. It insulates surfaces that must transfer heat. It transforms the arteries of a cooling system into narrowing, calcified corridors that push temperatures higher with every passing cycle. And in a nuclear plant, rising temperatures in the cooling loop do not lead to inconvenience. They lead to emergency. So the chemistry teams at Palo Verde wage a constant, invisible campaign, injecting anti-scaling agents, monitoring mineral concentrations in real time, flushing, and retreating system water around the clock. It is a battle measured in parts per million, fought inside pipes that carry water hot enough to scald steel, in a facility where the margin between operational stability and reactor crisis is thinner than most people would ever want to know. And then there is the supply itself. The Hassayampa Pipeline is the singular artery feeding this entire operation. 36 miles of buried infrastructure stretching across open desert, exposed to ground shifts, seismic activity, and the relentless thermal expansion of Arizona's superheated Earth. If that pipeline ruptures, if the flow stops for any sustained period, Palo Verde does not have an ocean to fall back on. It does not have a river to tap. The plant maintains on-site reservoirs, but those reserves are finite. They are a buffer, not a solution. A prolonged disruption to the pipeline would force operators into emergency protocols, racing against a countdown that ends with reactor shutdown, or worse. Even when the pipeline flows without interruption, the desert extracts its own toll. The cooling towers at Palo Verde do not recirculate water indefinitely. They lose it. Millions of gallons vanish every day, pulled upward through the towers by superheated air and launched into the atmosphere as steam. In a humid climate, some of that moisture might condense and return. In the Sonoran Desert, it simply disappears, absorbed into air so dry it drinks moisture the way sand swallows rain. The plant must pump water in faster than the sun and wind can steal it away. An evaporation paradox that turns every summer day into a race with no finish line. The men and women who manage this facility understand all of this. They work 12-hour shifts inside an isolated industrial fortress surrounded by miles of empty desert, monitoring systems that balance on a knife edge between triumph and catastrophe. They are not just operating a power plant. They are keeping a 3-gigawatt machine alive inside an environment that is, at every molecular level, trying to dismantle it. The desert does not attack with drama. It attacks with patience, with heat, with corrosion, with evaporation, with the slow, grinding volatility of a landscape that was never meant to host this kind of power. And the engineers know something the public rarely considers. The ghost in this machine is not a mechanical failure waiting to happen. It is the cumulative pressure of 1,000 small tolerances, each one held in place by human vigilance, in a place where nature offers no forgiveness and no second chances. Stand back far enough, and the numbers begin to lose their meaning. 3 reactors, over 3,000 megawatts, enough electricity generated every single day to power roughly 4 million homes across 3 states. Palo Verde is not just a power plant. It is the invisible engine of the American Southwest, the silent pulse behind every air-conditioned office tower in Phoenix, every glowing strip of neon on the Las Vegas skyline, every server farm humming in the sprawling tech corridors outside Los Angeles. When the desert sun drives temperatures past 115 degrees and millions of people reach for their thermostats at the same moment, it is Palo Verde that answers, quietly, relentlessly, without interruption, and almost no one knows it is there. That is the fragile truth at the center of this story. An entire civilization, one of the fastest growing population corridors on the planet, has built its survival on a foundation of treated sewage and controlled nuclear fission, held together by a single buried pipeline and the vigilance of a few thousand engineers working in shifts in the middle of nowhere. The modern Southwest does not just depend on Palo Verde for comfort. It depends on Palo Verde for survival. Without it, the grid destabilizes. Without the grid, cooling systems fail. And without cooling, the desert does what it has always done. It reclaims everything. If Palo Verde goes dark, the Southwest does not experience an inconvenience. It experiences a crisis. And yet, there is something else embedded in this story, something that points forward rather than back. As climate patterns shift and fresh water supplies tighten across the globe, the model that Palo Verde pioneered half a century ago is starting to look less like an anomaly and more like a prophecy. A nuclear facility that runs on recycled waste. A power source that produces 0 carbon emissions during operation. A cooling system that takes what a city throws away and transforms it into the one resource that keeps the lights on for millions. In a world that is running out of clean water and running out of time, the Palo Verde blueprint, squeezing energy from fission and coolant from sewage, may not be a curiosity of American engineering. It may be the only viable path for a thirsty, overheating planet. That is the paradox this place leaves you with. We did not build Palo Verde because it made sense. We built it because we had no other choice. Because a growing nation needed power in a place where power had no right to exist. And in doing so, we created something that transcends ordinary engineering. A fortress of defiance, standing alone against the oldest and most patient force on Earth, converting the waste of human life into the energy that sustains it. Tonight, when the sun drops below the horizon and the Sonoran Desert cools into darkness, Palo Verde will still be out there. 3 reactors glowing behind concrete walls, steam rising in pale columns against a black sky. A machine that was never supposed to work, breathing steadily in a land that was never supposed to support it. We did not just build a power plant. We built a guardian, and it is the only thing standing between civilization and the desert that surrounds it. If this story changed the way you think about the invisible systems keeping our world running, subscribe to Project Mystery. There are more marvels buried beneath the surface, and we are just getting started.